Okay, so we're going to go over adding and subtracting rational expressions, which we just kind of just did with multiplying and dividing. We still want to simplify first. Okay, so when we look at the numerators of both of these fractions, they're as simple as they're going to get. The denominators, though, are both quadratics that we can factor. Okay, so we'll quickly go through the factoring of each. Excuse me. Our x squared minus 9, do you know what type of factoring we can use to solve that?
Squared.
Exactly. Right, so x squared minus 9 is essentially just x plus 3, x minus 3. We square root the first and last value. And in our other one, we have a trinomial. Okay. So we need a number that is going to multiply negative 10 and add to negative 3. Do you know what we can get? I think it should be x minus 5 and x plus 2. Good. So what we can do now is we can replace both of our denominators with those values. Okay, so that now we're in that form. So that we originally had x minus 1, x plus 3 times x minus 3 plus x plus 7, and then x minus 5, x plus 2. And we'll write in our division signs here. Now, because this is adding, we really pretty much just want to state restrictions right now. Okay, so let's go about looking at the denominator stating restrictions. X plus 3 can't equal 0, and x minus 3 can't equal 0, because we know if we have a 0 on the bottom, it's numbers we can't divide by. We also have x minus 5 cannot equal 0, and x plus 2 cannot equal 0, which gives us 4 different restrictions. X can't be negative 3, x can't be positive 3, x can't be positive 5, and x can't be negative 2. So essentially, when we write them all together, x cannot equal negative 3, negative 2, 3, and 5. None of these would give us values. Okay, so this rational expression doesn't exist at those points. Now, because we're adding this, okay, in order to add two fractions, if you recall, we need to have common denominators. So we need this denominator to equal that denominator, but they're very different right now. Okay, so let's say we're just doing normal fractions, a half plus a fourth. Oops. Or, yeah, a fourth. In order to do that, I need to change this 2 into the 4. Okay, so I would multiply this fraction by 2, so it becomes 2 over 4 plus 1 over 4, which will give us 3 over 4. Now we can do that in this one. Essentially, this I'm going to have to multiply over on this side, and I'm going to have to multiply the other denominator by this one here. So what is that going to give us? Let's kind of write this out. The numerators will stay the same. X, I guess we should zoom out a little so we can see everything at the same time here. I have x minus 1, okay, divided by, in this case, and this will be a rather large number. We'll keep the original numbers, x plus 3, x minus 3, and then we're multiplying by x minus 5, x plus 2, and whenever we do the bottom, we have to do the top, so we need to multiply what was originally there by these values also, x minus 5, x plus 2, okay? And we still have to add that to, excuse me, what was originally there, x plus 7, divided by, and we're going to have x minus 5, x plus 2, and then we have to take our x plus 3, x minus 3, and again, wherever we do the bottom, we must do the top, so we have to do that on the bottom and the top, x plus 3, x minus 3. So now, this is quite a bit more complex page width. There we go. This question has become much more complex. Now, luckily, we know when we add these together, when we add all of these, what we're going to be doing here is our denominators are going to be the exact same. Okay. So our denominator is going to stay the same. We're just going to have one denominator, and we're going to be adding by all of these values here. we're going to have x plus 3, x minus 3, x minus 5, x plus 2. Okay? Now, here these become a little more complex. We're going to have to do, we can do some distributive property to see if anything will eliminate each other. Because right now what's going to end up on the top is we'll do the left side here in yellow. Okay. All of those there, I'll write them in purple. That's x minus 1, x minus 5, x plus 2. All of that needs to be added to, and we'll do the other one in green here, all of these guys. Okay. X plus 7, x plus 3, and x minus 3. So all of that needs to be added together. So there's quite a bit of distributing we're going to have to do here, because right off the bat, I can't see anything that's going to eliminate from both. Is there anything that eliminates from both of them? So in order for it to eliminate here, I'd have to have, for instance, x minus 5 and x minus 5. I'd have to have an x minus 5 here. And then we could eliminate all three, okay? Because think of it like they're separate. But we don't have anything that occurs in both, do we? No, we don't. So there's no eliminating here. So now we take our distributive property and we're going to distribute what's on the top here, okay? Now, quickly, I don't think they just want to simplify. This could be considered a simplified version if, when we go later on, we distribute and nothing essentially eliminates. Okay, let's find out what happened. So, have you done distributive property with stuff like this before? So let's kind of just do the first two to start. Okay, and we'll just focus on those. We'll leave the bottom out and rewrite it after. We're going to have x squared, x minus 5, so it's going to become x minus 6, and then plus 5, multiplied by x plus 2. And then the other one, so I have to add that, that's going to become x squared plus 10x plus 21, still times x minus 3, okay? And then the next line, I'm just leaving the denominator out right now to make it simpler. This will become x cubed minus 6x squared plus 5x plus 2x squared minus 12x plus 10. Okay? That's the one in red. X cubed. Do you see what I'm doing here? Yeah? Okay. Plus 10x squared plus 21x minus 3x squared. I'm trying to fit it all in. Minus 30x minus 63. And bracket. Got a little too long there. So let's simplify each of these brackets. Well, we only have one x cubed, so x cubed. X squareds we have, so negative 4x squared. X's we have becomes negative 7x, and then plus 10. Okay? It's going to be added to. We have x cubed. Our x squareds, that's going to give us positive 7x squared. X's are going to become negative 7x, I believe, and then the last number is negative 63, it looks like. So the brackets can drop off and we can collect our like terms, okay? X cubed plus x cubed is going to give us 2x
Would that be
cubed.
negative 9x in that one? 21 minus...
Oh, yes, you're right. Yes, sorry. Negative 9x. Yeah. So when we add these together, we have x cubed and x cubed. Our squared, so when we add those together, we're going to get positive 3x squared. Okay. Here we're going to get negative 16x. And here we're going to end up with negative 53. So here's our numerator. Now we haven't talked about factoring these before, have we?
No.
No, we haven't factored it. So essentially this will be our numerator on the top. 2x cubed plus 3x squared minus 16x minus 53. And our denominator on the bottom, which was 3, 3, So x plus 3, x minus 3, x minus 5, and x plus 2. Now, because, and now this is completely dependent on how your teacher's going to want this question. Oh, I don't want to go that far. Because we ended up with a value on top here that we weren't able to factor. Like, in a subtraction question, you might find that the cubes drop off. And then we're left with another trinomial, which we might be able to factor into, you know, one of the brackets being the same here, and we can simplify farther. But because this went into a cube, and we haven't talked about factoring cubic functions, this is no simpler than this here. This at least gives us a lot of options, okay? So your teacher might have been fine with you stopping there, okay, and not having to do all the distributive property. But sometimes when we do it, we might find a value on top that we can factor again and then simplify farther, okay? So we have our restrictions, and both of these are the exact same. This one here and this one here, it's just really where your teacher wants you to end.